All right, so here we get to look at some exponential decay functions. We notice these are decay by looking at the base, same stuff that we did before. So my base is less than 1, so that means it's going to be a decay. Let's go ahead and draw out our parent function points. Remember, for decay functions, we're going to use -2, -1, and 0. And here we finally get to see why we want to use these. So if my parent function looks like this, y equals 1/2 to the 0 power, well, that means I have 1/2 to the -2. What does a negative exponent do? Remember that the negative exponent tells us to flip the fraction. Okay, so 1/2 becomes 2 over 1, and then it's looking at not a negative exponent anymore, 2 to the second power, and then that becomes a number that's really easy for me to work with. Okay, so all we have to do is raise it to the reciprocal power. That's it. So we have 1/2 to the -1. Reciprocal of 1/2 is 2. 2 to the first power is 2. And then finally we have this one, 1/2 to the 0 power. Well, anything to the 0 power we know is 1. Now we can go ahead and apply our transformations. So when we have h is -2, that means I'm adding 2 to each of these. That's 0, 1, and 2. And then my k is a +2, which means I'm going to add 2 to all of these. That's 6, that's 4, and that's 3. And here also, still, this is going to be the location of my horizontal asymptote. So we can go ahead and draw that in at +2. And then we'll go ahead and plot our points. First point I have is 0, 4. Next point I have, I'm sorry, not 0, 4, it's 0, 6. Next point I have is 1, 4. And then the next point I have is 2, 3. And now we can start to see that, hey, instead of growing exponentially fast, we are getting smaller exponentially fast. And I totally missed the dot, so let's try that again. There we go. That's better. So it's kind of like it's a reflection, right? The whole thing has just been flipped vertically, or horizontally, I should say. As you get further along the axis on the right-hand side, you're going to get smaller. As you get further along the x in the negative direction, you're going to be getting larger values. And that's going to be our shape for exponential decay. Let's go ahead and take a look at another one. So here we have f of x equals 1 over 3. Again, we can see that my base, 1 over 3, is less than 1, so that means it's decay. Go ahead and plot your, or make your table. Choose your -2, -1, and 0 as your x values. And then we're going to plug in. My parent function is y equals 1 over 3 to the x. So that means we have 1 over 3 to the -2. Reciprocal of 1 over 3 is 3. 3 squared is 9. Next point, 1 over 3 to the -1 is going to be 3 to the first power, and that's 3. Next one, 1 over 3 to the 0 power. Well, that is 1, and we've got all our points. Now we just need to apply the transformations. I have x plus 4. That's actually shifting to the left, so I'm subtracting 4 to each of these. -6, -5, and -4. My k is a +1, which is also going to be the location of my horizontal asymptote. I like to draw that in early. And then we'll add 1 to each of these. Gives me 10, 4, and 2. And now we can go ahead and plot our points. First one's going to be at -6, 10. Next one's going to be a -5, 4. Next one's going to be a -4, 2. Another nice smooth curve, and there's our exponential decay function. Okay? Domain and range for this one. Domain is still all real numbers. And then our range is going to be y must be greater than or equal to 1. That's it, guys. That's exponential growth and decay functions. Thanks for watching. Go ahead and get started on your assignment.